Today we're going to learn about comparing linear and nonlinear functions. A linear function shows a constant rate of change, which means it becomes a line. Okay, so linear means line. So we're going to have some constant rate of change, whether it's positive, negative, or a horizontal zero rate of change. A nonlinear function does not have a constant rate of change, so the graph is not a line. So we're going to identify these different functions through different ways. First, we're going to look at the tables, and we're going to see if they represent the graph of a linear or nonlinear function. If it is linear, then it's going to add or subtract by the same amount. So as I'm looking at my first one, I have 3 to 6 is plus 3, 6 to 9 is plus 3, and 9 to 12 is plus 3, so that part is good. Now 40 to 32 is negative 8, 32 to 24 is negative 8, and 24 to 16 is negative 8. Because they go up and down by the same amount, this is a linear graph. Now let's do the second one. 1 to 3, that goes up by 2. 3 to 5 goes up by 2, and 5 to 7 goes up by 2. Now 2 to 11, that goes up by a positive 9. Then 11 to 33 goes up by a positive 22. And then 33 to 55 goes up by a positive 55. Because they go up by different amounts, this is a non-linear graph. They have to add or subtract the same amount each time, like our first example. So go ahead and try the next two on your own. Check back and see if your answers are correct. All right, you should have gotten linear for both of them because they added and subtracted by the same amount each time. In the first one, I had that it was going up by 7s as my y's were going down by 5s. In the fourth one, my x's were increasing by 2s while my y's were decreasing by 4s. To find out if a graph is linear or nonlinear, it's pretty simple. It has to be one straight line. Because this first one incorporates two straight lines, this is not a linear graph. It is nonlinear because there are two parts to this graph. However, underneath it, there is a horizontal line, and it's 1, so it's linear. Go ahead and write your next two options and check back and see if your answers are correct. All right, these are pretty simple. We had a nonlinear line because it curves, and then a linear line because it's one straight line. Now we're going to look at functions and from equations. So it's going to ask if these equations represent a linear or nonlinear function. Basically, it will be a linear function if we can put it into slope-intercept form, y equals mx plus b. As we've learned in the past, that is a linear function. So this very first example is already in slope-intercept form, so this is a linear function for sure. Now the second one has x squared. In slope-intercept form, you cannot have a square to your variable, so because of that, this is nonlinear. Go ahead and try the next four on your own. See if they are, in fact, a linear function or nonlinear function. Remember, they're only linear if you put it into slope-intercept form. Check back and see if your answers are correct. All right, so these actually were all linear functions. I rewrote them to show you that they all went into slope-intercept form. This first one, we had 4/3 x is really what this fraction means. So that's our slope. The second one, although pi is a symbol, it really states 3.14 and goes on as an irrational number. So that can be a slope. The third one that you guys had to do, you can distribute and put it into slope-intercept form. And the fourth one is hoi. It's a horizontal line with a zero slope, and its y equals a number. So if you graphed it, you would graph it at 4.7 and have a horizontal line. So that is a linear function. Now we're going to use the what we know about functions and linear functions and nonlinear functions, and we're going to graph two different accounts. So it says account A earns simple interest and account B earns compound interest. The table shows the balance for 5 years. Graph the data and compare. So we are going to go ahead and do that. So I'm going to go ahead and make account A green, and I'll do account B in blue, and we actually do graph it. I'm going to label the graph so we have years underneath. And I'm going to just spread it out a little bit. 3, 4 for 5 years. And then we're going to talk about the balance over on the y-axis. So as I'm looking, I'm kind of thinking that I should go up by maybe tens. I think I'm going to start with a break in the graph and start at $80 so that we can see where the balance goes. Now, we don't have anything less than 100, so that should work out for us. So as I'm labeling this, I'm just going up by tens to see what's going on. 170, 180. All right, so this first account, at year 0, we have $100. That means they put $100 in their account on the first, at the very beginning. Year 1, they had 110. Year 2, they had 120. 3, 130. 4, 140, and 5, 150. So this is account A, as we've labeled. Now let's do account B. So we started with 100. It went to 110 after the first year. It went to 121. So I'm going to guesstimate where that is. Then 133, 146, and then, oops, I didn't skip a line. Whoops. So it goes to 133, then 146, and then 161. So that is our account B balance. So then it says to compare the graph. So let's talk about this. Well, you can kind of see it happening, but account A is linear. It goes up by $10 a year. And account B is nonlinear. You guys can see that it is kind of curving up as time goes on. So we all started with the same amount with $100, yet account B over time ends up getting more money as time goes on. So that's how we will compare these graphs.